Hi, welcome back to Math 111. We're going to continue section 1.4 and talk about function notation. So in the last video, I introduced functions, just the basic concept and definitions of functions. Today, we're going to talk about function notation. And function notation is just a way to, maybe we're going to talk about, yes, a way to talk about the names of functions. Now, we've already talked about a lot of this. We've already talked about the fact that the domain of function is the set of inputs that go into that function. If we think of our functions as a factory, the inputs are the things that factory knows how to process. And a range is the set of y's, or the outputs, the things that factory can produce. We've already talked about the fact that a function is a process by which each input is matched to only one output. In other words, no repeated x's, right? You can have repeated y's, but no repeated x's in your set. And so what we haven't talked about is this definition, this little word, this little notation right here, this f parentheses x. That does not mean f times x. What that means is f of x. And this should not be brand new to you. You should have seen this before. What that means is we're going to take some value x and we're going to do to it whatever f says to do. Y and f of x are the same thing. The value of y is completely dependent upon the choice of our x coordinate. X is the one we get to choose. Yeah, we can choose either one, but typically we choose x. X is the independent variable. And it can also be called the argument of f, because it's what we're going to define f, the function, in terms of. Y depends on x, so y is the dependent variable. Usually we will define functions in terms of an algebraic process. So suppose we define a function f. You know, f is just a name. I could just as easily call this thing Francois. F's easier to spell, okay? So I'm going to take this function f, and it's going to tell me to take some real number and multiply that real number by 4 and then add 3. So I say, okay, I want to do that to 5. So my first step is I take 3, multiply it by 5 and get 15, and then I add 4 to get 19. That's not so hard. In function notation, I would write that f of 5, or Francois of 5, or f's really a lot easier, f of 5 equals 19. We take the input of 5, we apply the process of our function, which we have named f, and that gives us an output of 19. We can write this algebraically by saying f of x means take x, multiply by 3, and add 4. That's all there is to it. That is function notation in a nutshell. F of x equals 3x plus 4. That means the function f takes whatever we feed it, whatever number we feed it, multiplies that number by 3 and adds 4 to it. F of 5 would be 19. F of 2 would be 10. F of 0 is 4. Make sure you know how we got those. If not, ask me the question. So let's do this for something that's a little trickier. So let's see. I did not do all of this out ahead of time. I want us to do this together. So I'm going to turn my Fizzy Whopper here into a pen. And then you're going to have to put up with my bad writing. It messes with my let me see if the stylus will work here. Hold on a sec. got a stylus that I think might work. My soft squishy ones don't work, but I've got a different kind here. So let's try this. This would be kind of cool if I could turn this into like a whiteboard and you could actually read it. Let's see. Oh yeah, that's okay. All right, so let me erase this. So what we have is we have the function f of x equals negative x squared plus 3x plus 4. What that means is f takes some number, whatever we feed it, squares it, multiplies that squared value by -1, adds that to 3 times that number, and then adds 4 to that. Okay. The simpler way of evaluating a function is just take, so if f of x equals negative x squared plus 3x plus 4. And if I want to take f of -1, what I'm going to do is I'm going to go onto the right-hand side and replace all of my x's with -1s. Okay? Now we do a little arithmetic. -1 squared is 1. So this is -1. Plus 3 times -1 is going to be -3 plus 4. -4 plus 4 is 0. So f of -1 equals 0. That's not so bad. Let's do another one. Let's find f of 0. Again, we go to our function definition and replace all of the x's with zeros. So negative of 0 squared plus 3 times 0 plus 4. 0 squared is 0. Times -1 is still 0. Plus 3 times 0 is 0. Plus 4. And f of 0 equals 4. Yeah? Not too bad, right? Let's try with 2. I'm running out of space, so I'm going to erase. You don't have all this down, you can pause it and bring it back. It's one of the beautiful things about recorded lectures. You can always back up. Awesome. All right. Go back to my pen. So f of 2. Take all my x's, replace them with 2's. -2 squared plus 3 times 2 plus 4. 2 squared is 4. Negative sign in front makes that -4 plus 6 plus 4. And f of 2 equals 6. Right, you've done this sort of stuff before. So it's the same thing as plugging in that value. Now, what happens though if you're asked to find something like f of 2x? Well, we do pretty much the same thing. Actually, we do exactly the same thing. It does not matter what is inside those parentheses. We replace all of our x's with whatever that might be. So let's take f of 2x. That's going to be negative, 2x squared plus 3 times 2x plus 4. See what we did? We went back to our functional definition and replaced all of our x's with 2x because that's where we're evaluating our function. 2x squared is 2x times 2x, so that's going to be negative 4x squared. Plus 3 times 2x is 6x plus 4. Aw, I still have x's. That's okay, because I have an x in my parentheses, so I expect to have an x. I've got an x on the left-hand side. I've got f of 2x. So I expect that that's going to equal something like negative 4x squared. Sorry, I was writing and talking at the same time. 4x squared plus 6x plus 4. Okay? Let's see how that is different than 2 times f of x. This 2f of x, what that really means is 2 multiplied by f of x. But what is f of x? F of x is this. So that's really just 2 times negative x squared plus 3x plus 4, or negative 2x squared plus 6x plus 8. Yeah? All right. So this would be, so f of 2 times f of x is negative 2 times x squared plus 6x plus 8. Okay? Right. We will talk about this in class too. But I need you to have seen this before class so that we can answer questions and do problems together. Because we don't have as much time as I would like us to have. Okay, so let's work now on the last one. As soon as I get all my marks erased. Not all of them. I'm going to keep these over here. All right, so let's talk about f of x plus 2. Sometimes it's confusing to students. But remember, whatever I put in my parentheses on the left, that just goes everywhere I've got an x. On the right. Okay. Now I need to do some simplification. I need to remember how to square x plus 2. X plus 2 squared is x plus 2 times x plus 2. So we've got to FOIL that, and we'll get x squared plus 4x plus 4. And now I'm just going to bring the rest of it down. Now I'll distribute my negative sign. So I get negative x squared minus 4x minus 4 plus, let's distribute the 3. So we get 3x plus 6 minus 4. Combine like terms, and we'll get negative x squared minus x plus 6. So f of x plus 2 equals negative x squared minus x plus 6. Okay? All right, let's try this last one. It's pretty simple. The last one says f of x plus 2. So we're just going to take our function, our negative x squared plus 3x plus 4, and add 2 to it. Let's see how that works out. So we've got f of x plus 2 equals f of x, which is negative x squared plus 3x plus 4. That part's f of x. And now add 2 to it. And we get negative x squared plus 3x plus 6. All right, so I'm running out of room. I am going to put that up here. I'm going to erase this. And I'm going to come right here. And I'm going to say f of x plus 2. Sorry. F of x plus 2 equals negative x squared plus 3x plus 6. I want to make sure you understand why this one is different than that one. Because of where the 2 is. If the 2 is inside the parentheses, it means we plugged a whole x plus 2 into the function, and depending on our function, that can be significantly different than just adding 2 to the end, which is what this second thing means. Okay? All right, let's do the last one. Let's work through this last one together. Let's work through f of x plus f of 2. So now f of x is negative x squared plus 3x plus 4. F of 2 is the negative of 2 squared plus 3 times 2 plus 4. So I've got negative x squared plus 3x plus 4. So 2 squared is 4, with the negative sign means minus 4, plus 6 plus 4. So we end up with f of x plus f of 2 equals negative x squared plus 3x plus 10. Okay, that's the basic function notation. It's just a shorthand way of giving a set of steps a name. And to evaluate that someplace, we just take whatever we want to plug in and shove it into where all the x's are on the right-hand side of the function definition. Okay? All right, now domain is the set of inputs that we can put in. Think back to our t-shirt factory. T-shirts are typically made out of cotton, maybe rayon, some sort of fabric. So we feed our t-shirt factory fabric. Pretty much any type of fabric, but we have to feed it fabric, right? What happens if I try to feed it rocks? Yeah, my factory breaks, yes. Mathematical functions are kind of the same way. I'm only allowed to put in certain things. Now, for mathematical functions, how we figure out what we are allowed to put in depends on our knowledge of how functions, of what's allowed and not allowed. So let's look, for example, at this function I've got up here. This guy, r of x equals 2x divided by x squared minus 9. Now, I happen to know that the number 3 is not an allowed input into that function. Why? If I put in 3, what am I going to get down here in this domain? 3 squared is 9, minus 9 is 0. Sorry, in this denominator. Can I divide by 0? No, that's not allowed in this universe, right? So, we know we cannot feed 3 into our factory. It breaks things. It tries to do stuff that's not allowed. That means my domain is all real numbers except for 3. All right, let's look at this some more. We're going to find the domain of these functions. So let's start with the first one. It's kind of ugly. We've got f of x equals 2 over 1 minus 4x over x minus 3. If we think about this in terms of fractions, we've got two denominators, right? We've got a fraction here that has a denominator. X minus 3 is a denominator. We also have a fraction here, a whole big fraction that has a denominator. 1 minus 4x over x minus 3 is a denominator. We need to make sure that both of those denominators are not 0, because we can't divide by 0. So if we write, so what we're doing here is we are looking for values that we are going to have to exclude from our domain. To do that, we're going to take our first denominator, x minus 3, and set it equal to 0. Solve that, we see that x equals 3. What that really means is we cannot feed 3 into our function. It really means 3 is an excluded value. Now look at this one. We're going to set the second denominator, this whole big guy, 1 minus 4x over x minus 3. We're going to set it equal to 0. Solve that, and you should be able to find that x equals negative 1. If you're not sure how to solve that, let me know. We'll walk through it. Okay? You can do it in class. What that means is that our domain is the set of all real numbers except for 3 and negative 1. We write that in interval notation as the portion of the number line that goes from negative infinity up to negative 1, non-inclusive, unioned with negative 1 up to 3, union with 3 up to infinity. This is a fancy way of saying x cannot equal 3 and negative 1. Okay. Let's try another one. Let's find the domain of the function, the square root of 4 minus 3x. We're going to start with the assumption that our domain includes all real numbers. Make sure we don't do anything silly. In other words, we don't want to do anything that if our calculator is set into real number mode, our calculator will yell at us. If I try to do something that's silly, like say take the square root of a negative number, my calculator is going to go, I can't do that. We're only working in the real numbers here. So no imaginary numbers, not yet. We'll get to those later. What that means is my radicand, the thing under the square root, my 4 minus 3x, must be greater than or equal to 0. It's got to be positive, or at least 0 or bigger. I can't take the square root of a negative number. Solve this and we get x has to be less than or equal to 4/3. In interval notation, that's negative infinity up to 4/3 inclusive. Now, I want you to realize what we did here was we found the domain. We said, all right, well, look, we can handle this. We can handle anything as long as my thing under my square root is positive. In the previous example, I said, okay, wait a minute. This is going to be easier to find what's not allowed. So we took and found the excluded values. Be sure you understand the process and what we're trying to do. Okay, one more. Let's find the domain of the function f of x that says take the 5th root of 4 minus 3x. Begin with all real numbers. Begin with that assumption and start looking for things that we can't do. Okay, what that means is we're taking a 5th root. Can we take the 5th root of a negative number? Yeah. The 5th root of negative 1 is negative 1. Plug it into your calculator. Make sure you understand that. Can I take the 5th root of 0? Sure. 5th root of any root of 0 is 0. And I can take the 5th root of a positive number. Okay? Yeah. 5th root of 1 is 1. Or 2 to the 5th is 32. So if you take the 5th root of 32, you will get 2. If you take the 5th root of negative 32, you'll get negative 2. So there's nothing I'll have to kick out. So the domain of this function is all real numbers, or in interval notation, we write it as negative infinity up to infinity. All right, I'm going to leave the rest of these for you to work. I've given you the answers here. If you can't get any of these, or if you don't understand something, please reach out on the forums. All right. So let's try a real-world problem. We are told that the height of a model rocket, t seconds above the ground, is the height of a model rocket is h in feet above the ground, t seconds after liftoff. And we're given this definition, this function that's defined in two ways. This is what we call piecewise defined function. What this says is that the height is -5t squared plus 100t, as long as t is less than 20. And it's 0 if t is greater than 20. Let's think about what that means. What that means is within the first 20 seconds after I launch my rocket, I can figure out its height using this function. This -5t squared plus 100t. If I'm more than 20 seconds after my launch, my height is 0. Height of 0 means on the ground, right? So my rocket has come back down. Oh, my rocket's only going to fly for 20 seconds? That's kind of sad. Okay. We want to find and interpret h of 10 and h of 60. Now let's think about it. H of 10 means we're finding the height of the rocket 10 seconds after launch. H of 60 means we're finding the height of the rocket 1 minute after we launch, 60 seconds after we launch. Okay, I used Desmos to graph this function. It looks like this. Here's what we're going to do. First, start with h of 10. H of 10, we start with 10. We figure out which of our two lines that falls into. Well, 10 is less than 20, so we're going to apply the first line. So h of 10 equals -5 times 10 squared plus 100 times 10, which if you do the arithmetic says h of 10 is 500. What does that mean? Well, on the graph, that's right here. Happens to be right there. What that means is that 10 seconds after we launch our rocket, it is 500 feet in the air. Let's find h of 60. 60 is definitely bigger than 20, so that puts us down here on the second row. H of 60 equals 0, because if time is bigger than 20, then height is 0. In terms of my graph, that's going to be down here, right? So 60 seconds after we launch, the rocket's back on the ground. Okay, that is it for this chapter. I know this has been a lot of information. Most of it's been review. Please be sure and work on your math every day and ask me any questions that come up, and I will see you all in class soon. Have a great night. Do good math.